Number 10 on page 242 asks us to solve the polynomial inequality 2x minus 2 times x minus 2 squared is greater than 0. Since it's showing to be greater than 0, we're looking for the parts of the graph that are positive or above the x-axis. So all these problems start by finding the zeros. So let's do that first. And again, this is similar to number 1. It's already factored, so we just have to set the factors equal to 0 and find our x-intercepts. So one of them is 7 over 2, and the other is going to be 2. So we have one repeated root, so that means we only have two distinct zeros. So setting up our sign chart, I'm going to draw a number line. The first one is at 2, right here. And the other one is at 7/2. So we want to pick a number before 2, between 2 and 7/2, and after 7/2. So before 2, I'm going to choose 1. Between 2 and 7/2, I'm going to choose 3. And after 7/2, I'm going to choose 4. Then I'm going to substitute those values into the polynomial inequality and determine the signs. And as was stated in the previous problem, we don't need the value of the inequality, just the sign of each part, so we can figure out the sign of the entire polynomial. So if x is 1, what we have is the first parenthesis will be negative, and the second parenthesis will also be negative, but we're going to square it. So the second parenthesis is always going to be positive. So we have a negative number for that section of the graph. Next, when we substitute 3 in, we get a negative value for the first parenthesis, and again, the second parenthesis will always be positive. So we have a negative section again. And that makes sense because if you think at x equals 2, we have a multiplicity of 2, which is even. The graph's going to touch and turn. So if it was at negative, it's going to touch and turn at 2 and continue back in a negative direction. And then finally, when x is 4 and we substitute that, the first parenthesis will be positive, and the second parenthesis, again, is always positive since it's squared. So that section is positive. So we only have one section of the graph that is greater than 0, and that is from 7 over 2 to infinity. And that would be our solution set for this problem.